John Horton Conway FRS is an English mathematician active in the theory of finite groups, knot theory, number theory, combinatorial game theory and coding theory. He has also contributed to many branches of recreational mathematics, notably the invention of the cellular automaton called the game of life. Conway is currently Professor Emeritus of Mathematics at Princeton University in New Jersey. Biography. Conway was born in Liverpool, the son of Cyril Horton Conway and Agnes Boyce. He became interested in mathematics at a very early age. His mother has recalled that he could recite the powers of 2 when he was 4 years old. By the age of 11, his ambition was to become a mathematician. After leaving secondary school, Conway entered Gonville & Caius College, Cambridge to study mathematics. Conway, who was a terribly introverted adolescent in school, interpreted his admission to Cambridge as an opportunity to transform himself into a new person, an extrovert. He was awarded his Bachelor of Arts degree in 1959 and began to undertake research in number theory supervised by Harold Davenport. Having solved the open problem posed by Davenport on writing numbers as the sums of fifth powers, Conway began to become interested in infinite ordinals. It appears that his interest in games began during his years studying the Cambridge Mathematical Tripos, where he became an avid backgammon player, spending hours playing the game in the common room. He was awarded his doctorate in 1964 and was appointed as college fellow and lecturer in mathematics at Cambridge University. He left Cambridge in 1986 to take up the appointment to the John von Neumann Chair of Mathematics at Princeton University. According to a 2015 biography, Conway has been thrice married and twice divorced, and has suffered 2 heart attacks, 2 strokes, and depression. He resides with his current wife, Diana, in Princeton. Research. Combinatorial game theory. Among amateur mathematicians, he is perhaps most widely known for his contributions to combinatorial game theory, a theory of partisan games. This he developed with Elwyn Burley-Camp and Richard Guy, and with them also co-authored the book Winning Ways for Your Mathematical Plays. He also wrote the book on numbers and games, which lays out the mathematical foundations of CGT. He is also one of the inventors of Sprouts, as well as Philosopher's Football. He developed detailed analyses of many other games and puzzles, such as the Soma Cube, Peg Solitaire, and Conway's Soldiers. He came up with the angel problem, which was solved in 2006. He invented a new system of numbers, the surreal numbers, which are closely related to certain games and have been the subject of a mathematical novel by Donald Knuth. He also invented a nomenclature for exceedingly large numbers, the Conway chained arrow notation. Much of this is discussed in the 0th part of ONAG. He is also known for the invention of Conway's game of life, one of the early and still celebrated examples of a cellular automaton. His early experiments in that field were done with pen and paper, long before personal computers existed. Geometry. In the mid-1960s, with Michael Guy, son of Richard Guy, he established that there are 64 convex uniform polychora excluding 2 infinite sets of prismatic forms. They discovered the grand antiprism in the process, the only non-Withoffian uniform polychoron. Conway has also suggested a system of notation dedicated to describing polyhedra called Conway polyhedron notation. He extensively investigated lattices in higher dimensions, and determined the symmetry group of the Leech lattice. Geometric topology. Conway's approach to computing the Alexander polynomial of knot theory involved skein relations, by a variant now called the Alexander-Conway polynomial. After lying dormant for more than a decade, this concept became central to work in the 1980s on the novel knot polynomials. Conway further developed tangle theory and invented a system of notation for tabulating knots, nowadays known as Conway notation. while correcting a number of errors in the 19th century knot tables and extending them to include all but 4 of the non-alternating primes with 11 crossings, topology proceedings 7118. Group theory. He worked on the classification of finite simple groups and discovered the Conway groups. He was the primary author of the Atlas of Finite Groups, giving properties of many finite simple groups. He, along with collaborators, constructed the first concrete representations of some of the sporadic groups. More specifically, he discovered 3 sporadic groups based on the symmetry of the Leech lattice, which have been designated the Conway groups. With Simon P. Norton he formulated the complex of conjectures relating the monster group with modular functions, which was named monstrous moonshine by them. He introduced the Mathieu groupoid, an extension of the Mathieu group M12 to 13 points. Number theory. As a graduate student, he proved the conjecture by Edward Waring that every integer could be written as the sum of 37 numbers, each raised to the 5th power, though Chen Jinggrun solved the problem independently before the work could be published. Algebra. He has also done work in algebra, particularly with quaternions. Together with Neil Sloan, he invented the icosians, algorithmics for calculating the day of the week. He invented the doomsday algorithm. The algorithm is simple enough for anyone with basic arithmetic ability to do the calculations mentally. Conway can usually give the correct answer in under 2 seconds. To improve his speed, he practices his calendrical calculations on his computer, which is programmed to quiz him with random dates every time he logs on. One of his early books was on finite state machines. Theoretical Physics. In 2004, Conway and Simon B. Kochen, another Princeton mathematician, proved the Freewill Theorem, a startling version of the no hidden variables principle of quantum mechanics. It states that, given certain conditions, if an experimenter can freely decide what quantities to measure in a particular experiment, then elementary particles must be free to choose their spins to make the measurements consistent with physical law. In Conway's provocative wording, if experimenters have free will, then so do elementary particles. Books. He has written several books including The Atlas of Finite Groups, Irregular Algebra and Finite Machines, Sphere Packings, Lattices and Groups, The Sensual Form, On Numbers and Games, Winning Ways for Your Mathematical Plays, The Book of Numbers, On Quaternions and Octonions, The Triangle Book, and in summer 2008 published The Symmetries of Things with Chaim Goodman Strauss and Heidi Bergiel. Awards and honors. Conway received the Berwick Prize, was elected a Fellow of the Royal Society, was the first recipient of the Polya Prize, won the Nemers Prize in Mathematics and received the Leroy P. Steele Prize for Mathematical Exposition of the American Mathematical Society. His nomination reads, a versatile mathematician who combines a deep combinatorial insight with algebraic virtuosity, particularly in the construction and manipulation of offbeat, algebraic structures which illuminate a wide variety of problems in completely unexpected ways. He has made distinguished contributions to the theory of finite groups, to the theory of knots, to mathematical logic and to the theory of games.